Is that right? Yeah, good. Thank you. Thanks very much. Okay, hi everybody. So that introduction kind of leads into my presentation because what I'm going to talk about today is the work that I did for my PhD project at the University of Aberdeen. The work, there was crossover between my PhD work and the work that I did at the Institute of Occupational Medicine, or IOM. So they're involved in this project, and the funding for the project came from the Health and Safety Executive in the United Kingdom. So they all get a shout out on the title page. Um, so, so the project that I did for my PhD thesis was studying inadvertent ingestion in the workplace, and it's kind of an emerging topic. So I think I'm going to spend a bit of time starting off, kind of just doing an introduction to what exactly that is. So when we talk about ingestion exposure, occupational ingestion exposure, there are a few different ways that it can arise. Oops, sorry. Uh, One of the ways is through the respiratory, through the whole kind of mucociliary escalator in the respiratory system. So basically, I suppose a lot of you are probably familiar with this. People breathe in dusts or things like that. They get caught on the cilia in the respiratory tract and then kind of moved back up into the mouth and then swallowed. So that's one way that people can ingest things, and it's quite easy to kind of, well, there are ways we can measure that by basically just measuring the fraction of air that we would expect, or the fraction of particles that we would expect to get ingested by that pathway. So there are ways of measuring that. Another way is from contaminated food. So that is, if you are working in an environment where you're eating in your workplace, or your lunchroom is dirty, and your food gets contaminated, that is another way. And this is kind of the impetus for this whole study. Is everyone sort of assumes that, okay, if you have a separate eating area and you keep that area totally clean and everyone has to wash their hands before they eat, then there will be no ingestion exposure. And so we're kind of questioning, is that really true? So that's another pathway of ingestion exposure. Another way is where there are particles in the air that deposit directly into your mouth. That does happen. Again, that can be measured or that can be controlled by controlling the amount of material in the air. And the pathway that I am focusing on is this what we call inadvertent pathway, because people aren't really aware that it's happening. And it's basically ingestion that happens when you have some kind of substance on your hands as a result of your work experience, or maybe on a pen or on something that you touch, and then you touch that thing to your mouth without kind of thinking about it, and then you end up having some kind of ingestion by that pathway. So that's what this whole project is about. So again, just to kind of sum up what inadvertent ingestion exposure is, it's unintentional exposure through the mouth, so it's ingestion, and it arises from hand to mouth and object to mouth contact, basically like while you're working, not when you're on your lunch break, but actually while you're working. So this is a conceptual model that was developed and published in 2006 by some colleagues of mine, and it's kind of just conceptualizes how this actually happens. So there is contamination somewhere in the environment. It ends up, contamination from the workplace. It ends up on surfaces and on hands, and it can go between surfaces and hands when people touch contaminated surfaces. Then the hands can touch this, what we call the perioral area, which is the area around the mouth. And from there, things can actually migrate directly into the mouth when you eat food, or when you drink water, or when you lick your lips. So things can move in between all these different compartments. They can move from the hands to the perioral area. They can move directly from the source to the perioral area. They can go from the hands directly to the mouth if you put your hands right in your mouth. So the surfaces, the hands, the perioral area, and the oral cavity, which is kind of the inside of the mouth, is these are the main things that we think about when we think about this type of ingestion exposure. Okay. Now, in that same study where they developed this conceptual model, they also kind of had a look at employment statistics in the United Kingdom and tried to figure out how many people are working in jobs where they might be exposed by this pathway. So they looked at jobs where people are working with materials that are gastrointestinally absorbed. If you swallow them, they could be absorbed systemically and they could cause some kind of health outcome. So they tried to figure out how many people are working in jobs where they might be exposed by inadvertent ingestion to these kind of substances, and they figured out that or they estimated that it's 4.5 million people in the United Kingdom. So that's 15.6% of the entire working population. And the main things that they thought were important, the main substances or classes of substances that they thought were important are pesticides, metals, pharmaceuticals, radionuclides, pathogens, and that says high molecular weight, but it should be high molecular weight allergens. So those are kind of things like animal allergens or like kind of food-related allergens. Okay, so it's so they concluded that it's not like it's not kind of a minor problem. This could be affecting a lot of people. So we don't know for sure if it is, but it seems like it's worth investigating further. And then they did another estimate where they looked at they tried to figure out. For two different scenarios, they tried to figure out how much of the exposure might be coming from ingestion. So they looked at, they thought about a lead worker and a pesticide worker, got some kind of data from the literature of sort of typical exposure levels in those areas. So for the lead worker, the air concentration of lead, is 1,000 micrograms per cubic centimeter. The literature suggests that people might have about 100 micrograms on their hand, and their total uptake, they estimated, would be 1,300 micrograms. And so they looked at kind of, in the literature, rates of how often we think people touch their face, how much would transfer from the hands to the face on that contact. To estimate how much from the hand would end up being ingested. And so what they concluded is that for the lead worker, 46% of their exposure might be coming from ingestion, 54% from inhalation, and 0% from dermal because it's poorly absorbed through the skin. For the pesticide worker, they did a similar thing and estimated that 20% is from ingestion, 1% from inhalation, and 79% from dermal absorption because this particular pesticide is well absorbed through the skin. So again, these are all estimates. This is just kind of theoretical, but again, it suggests that this should be investigated. So if we are going to investigate inadvertent ingestion exposure, we need some kind of way of measuring it. And these are some ways that have been suggested, some things that people have actually done. So one way is to go and get people to spit into a cup or something and then analyze the saliva to see what's in the saliva. That has a lot of problems associated with it because a kind of a fleeting snapshot of what is present in your saliva is a poor representation of what you have actually ingested because you're constantly swallowing. So that doesn't work very well. Lip or face wipes are another idea where you just go, it's kind of the same way that you would do like a hand wipe or another wipe on another part of the skin for dermal monitoring. You wipe the face or the lips to see how much is possibly being ingested or how much is on the perioral area, which is one of these important compartments that we talked about earlier. That has some of the same limitations as the saliva sampling, although things on the lip or face possibly stick around longer than things that are actually in the saliva, so it might be a bit better, but we don't know. Biological monitoring is kind of surefire way of doing it, you can definitely find out how much, or if you have a good biological monitoring method, I suppose, you can get a good idea of how much exposure people have. But the problem with that is it's not specific to ingestion. So you don't know, you can't actually use that to tease out how much is coming from ingestion unless you do this like a full kind of monitoring campaign with all different methods of assessment, which you could do. But again, you'd have to make inferences about ingestion. You're not doing it really directly. And another way that people have suggested is to do exposure modeling. So this is something that they're actually doing a lot of in Europe. Not so, I haven't seen so much of it here, but basically it's looking at exposure, figuring out how much, figuring out how exactly exposure works, doing some kind of lab experiments, pairing that up with field measurements, and then using some a model to estimate how much exposure you're getting. So that's, again, this is another flawed way of doing it, but it's another idea of how you could estimate inadvertent ingestion exposure. So after all that introduction to the topic in general, this is the objective of my PhD thesis work. The main kind of objective really was to identify and quantify some of the determinants of inadvertent ingestion exposure, because this is, again, is something that we don't know very much about, and we wanted to learn more. And then also the kind of outcome was we were hoping to develop a generic screening model. So this is the kind of predictive exposure model that I was talking about. So a generic screening model where you could use it for any kind of substance in any kind of workplace to estimate exposure by inadvertent ingestion. So that's what I was trying to do. So now I'm going to talk about how exactly I went about this and what we found. So the approach to the subject was, first of all, we started with a literature review where we looked at what do we already know about this topic. So that's, you know, where you always start with these things. Then we took what we learned to develop some experiments that we did in the lab to test out how inadvertent ingestion exposure might happen, and then we did some observations in real workplace. So we did lab experiments and field work. We also then collected some exposure data, which were hand and perioral wipes in the field. Then we put all that information all together to develop a model, and then we validated the model against the measurements that we took, the hand and perioral wipes. So that's kind of overview of what we did. I will go into more detail about all of these things. So phase one, the literature review and determinants of exposure. So we had a look to see what was known about this kind of exposure. And there's not a lot, but there is some. There has actually been a lot of work done on studying children because they do touch their hands, and they touch their they put things in their mouths all the time, especially little children. So that is a concern in homes where there are like a lot of people get pesticides sprayed in their homes if they live in an area where there are where these kind of insect infestations are a concern. So, but then it's a problem if there are kids crawling around on the floor getting pesticides on their hands and then putting their hands in their mouth. So there have been studies on that among children, so we were able to use some of that information. And there has been a little bit of work done in occupational settings as well, mostly among people exposed to metals, like particularly lead. So from this literature review, we were actually to identify some things that we thought might be determinants of exposure. So the first one is dermal exposure on the hands and the arm. In order for you to get stuff from your hand into your mouth, it needs to actually be on your hand or maybe your arm in the first place. Another determinant is the surface loading of objects that contact the mouth. So it's not just from contact with your mouth that you might put like an object in your mouth. Like I've seen people like take off their glasses and put the arm of the glasses in their mouth, or put a pen in your mouth, chew a pen, that kind of thing. So there needs to be, you need to know how much of this substance is on the object. Another determinant is the actual rate of contact between the hand and the object and the perioral area and the mouth. So how often is this actually happening? The contact surface area, so how much of the object or of your hand are you actually putting on your face or in your mouth? And then these two last points are transfer efficiencies. So which I will describe on the next slide in more detail. So the transfer efficiency for the hand to the object, the mouth, or to the perioral area. So this is kind of a concept that we've talked about a lot in this project, which is the transfer efficiency. And so what that means, it's the amount of material that moves from one surface to another following contact. So for example, if you have something on your mouth, what proportion of that is going to transfer, or sorry, if you have something on your hand, what proportion of that is going to transfer to your lips if you touch your lips? So we have this very simple equation. The transfer efficiency is the mass on the recipient divided by the mass on the donor. So the recipient is the lips in my example, and the donor is the hand. Yeah, and it's relevant to this inadvertent ingestion exposure, and it also has it's also relevant to dermal exposure, because one of the ways that dermal exposure happens is if people touch contaminated surfaces. So you want to know how much of the material on the surface is going to transfer to the skin. So so we did find a lot of information in the kind of dermal exposure literature on these transfer efficiencies, and we were able to extract that information to use in our project so we got so much well, we didn't get a lot of information, but we got some, and we thought that it was going to be useful for our project, and we thought it might be useful for other people too, especially people studying dermal exposure. So we put it all into a database and then put it online, so anybody can get a hold of this now, where we've tried to identify all the available transfer efficiencies that are published. So this is online if anybody's ever interested. You can search through them. You can kind of scroll through them. There are 534 transfer efficiencies, plus contextual information on the kind of scenario under which the transfer occurred. For 38 substances, most of them are pesticides, but there are a few other substances like different types of dusts and things like that. And the other thing that we found is, when we extracted all this transfer efficiency information, is that 84% of the data related to surface to hand transfer, so transfer from a contaminated surface to a hand. So it was about dermal exposure, but it didn't really tell us the next step, which is transfer from the hand or an object to the mouth. So we had to do some lab experiments to fill in some of the gaps in that in the knowledge. So that was phase 2 of the study. So we did some controlled laboratory experiments where we got some volunteers into the lab and asked them to kind of carry out some exposure simulations. We studied a few different things that we were interested in that we didn't have any data on. The effect of particle size and solubility on oral transfer. And so oral transfer is how much, like if you actually put something in your mouth, how much is actually going to stay in the mouth. So if you put an object in your mouth, directly in your mouth, will all of it stay in the mouth, or will some of it stay on the finger, for example? We don't know. And then, is there an effect of glove use on this transfer? So would more transfer from your bare finger than from a glove, for example? What about respirators? Because people kind of wear respirators on their face. If you wear a respirator, are you going to get stuff on the perioral area, the area surrounding your mouth? Direct transfer from an object to the mouth, and transfer from the arm to the perioral area, because that's another thing people do. People sort of wipe their face with their sleeve, and they might have some kind of hazardous substance on their sleeve, or on their arm. So we looked at that as well. And this is kind of an example of one of the experimental methods. I'm not going to go through everything that we did in these lab experiments, but as an example of how we did this, we spiked the surface. So, for example, a hand, somebody's finger, actually. We would spike it with a known amount of some kind of tracer substance So we did for everything, we did one liquid and one powder. So we used vinegar and calcium acetate. Where we were, for the vinegar, we were able to analyze the acetic acid, and calcium acetate, we were able to analyze the acetate. So we spiked a known amount using either a pipette or some kind of gravimetric method onto the hand. Then we used deionized water, moistened gauze wipes, and saliva samples to assess the transfer to and from skin in the mouth. And we had every experiment we did, we had we repeated it 4 times with 4 different volunteers. And then this is just kind of another, this is kind of a diagram to sort of show how exactly we did this. So we started off, we had the volunteer rinse out their mouth with deionized water to make sure that it was kind of as clean as possible. We had them clean their hands as well with deionized water. Then we did a face wipe and saliva sample just to see what the kind of baseline level of these things would be on their skin. Then in this scenario, we had the person either press a little boat with the powder in it that we could then weigh, so we would know how much was on their finger, or we would use a pipette to put liquid directly onto their finger. Then they would either insert 2 fingers in their mouth and then spit out their saliva, so we would know how much went into the mouth, and then we could calculate the transfer efficiency. Or we would have them press 2 fingers to their mouth, and then we would wipe their face to see how much ended up on their face, and then we could calculate a transfer efficiency. So these are just some of the results from that particular experiment, and we did similar things for a lot of different scenarios. So in this scenario, so there's this direct transfer where people put their finger directly in their mouth and then spit, or there's the indirect transfer where people put their finger on their face and then we wipe the face. And so we had so these are this is the average in the middle here, and then these are the 95 confidence intervals around the mean. So for this direct method, you can see there's really wide confidence intervals, and I think that's because we did the analysis in saliva, and saliva, the lab people told me, is very difficult to deal with because it's very there's a lot of organic material in saliva, and it's hard to kind of get past that to look at the thing that you actually want. So there's a lot of uncertainty in these saliva samples. With the wipes, there was the confidence interval. So these are wipes of the face, and the confidence intervals are much smaller. So we had more confidence in these results. So what we did, basically, we kind of compared bare skin, cotton glove, and a nitrile glove for the calcium acetate, the powder, and vinegar, the liquid. And generally, we found that there was most transfer from the bare skin and the nitrile. The bare skin and nitrile resulted in more transfer than the cotton, but it was hard to really tell anything, especially in this scenario because the confidence intervals are so wide. So anyway, that's not really that important, but it's just kind of an example of how we did this. So basically, we took all this lab data from all the scenarios. We computed the transfer efficiencies and then added all the data to the transfer efficiency database. So that's all in the database now. It's publicly available in case anyone else ever wants to use it. And we were able to supplement the very sparse available data on oral and perioral transfer. So that was good. So now that we have all this kind of lab data on ways that the transfer can occur, we wanted to go out into the field and see how does this actually work in the workplace. So, oh, my pictures are covering this up. Oh, sorry. But anyway, I remember what it said. The objectives of the field work. One thing we wanted to do was we wanted to observe workers, to look at their hand-to-mouth behavior, to see what sort of thing, if there are ways that we can predict who's going to be doing more of these kind of contacts, if people actually are doing this kind of contact. We wanted to identify the determinants. We also wanted to collect some field measurements of hand to perioral exposure. or hand and perioral exposure. So we wanted to wipe people's hands, wipe their perioral area, and kind of compare the two, and and kind of see if it is actually valuable to collect these perioral wipes, if that tells us anything. So we recruited 5 work sites in the United Kingdom. We focused on metals because when my colleagues did their work, and they tried to figure out who's most likely to be exposed by the inadvertent ingestion route. People working with metals that was the largest group of people who might be exposed by inadvertent ingestion. So that was one reason why we chose metals. Another reason why we chose metals is because they're easy to analyze. So it was that we could kind of maximize the number of samples we could get if we used metals. So we recruited 5 work sites. There was a smelter, some metal processing, and some manufacturing facilities. And these, I should say, actually, these were because it was actually quite hard for us to get people who were willing to have us come in and observe their workers. So these were all quite large companies that they all had, health and safety teams, which was how we got into them. Their health and safety teams were interested in our study. So what we found might not be reflective of smaller companies. But anyway, there isn't very much information in this area, so we thought that it was a good place to start. So we recruited these work sites. Our contacts helped kind of put us in touch with work teams who were working with metals and might have some kind of dermal exposure. And then we recruited 38 workers across these different sites. And what we did for all these 38 workers, we did a systematic wipe of their left hand, their right hand, and the perioral area with SKC ghost wipes. We did them at the beginning of the shift, just to look at baselines and kind of take home exposure and that sort of thing. And then we also did the middle and the end of the shift. We took the wipes back to the lab and we analyzed them for metal content by ICP-AES, and we looked at these metals, which we chose based on what they were working with. So these are the metals that they were dealing with. So those are the ones that we analyzed, and it differed by the different work facilities. So some people were exposed to chromium, some weren't, and so we only looked at it for people who were actually exposed to it. We took the average of the middle and end shift measurements for each area because we found that there was no significant differences between the two, and then used that as kind of our exposure endpoint when we did our analysis. So that was the one part of our field work. The other part was the observations that I talked about earlier. So a subset of the workers who were involved in this wiping, they were observed during their normal work activities. This was very time-consuming. Me and another person, we went out and did 60-minute observations. So we would basically shadow the worker while they were doing their work activities, and then we had an iPhone app where we would count. We press a button every time they had some kind of contact, and we had a little form where we could, record what type of contact it was. So if they touched their face, that was one type of contact. If they put something in their mouth, that's another type of contact. So but one thing we were very concerned about is there is this so-called Hawthorne effect, where people, if they know that they're being watched, they try to exhibit desirable behaviors. So we didn't want people to know that we were watching their hand-to-mouth behavior. Another thing, I guess, is if people know that we're looking at their hand-to-mouth behavior, they might actually start doing it more because they're kind of worried about it. So I don't think that in doing this there was any real way to avoid affecting their behavior in some way, but we didn't tell them that we were watching their hand-to-mouth contact, so we could have some degree of reassurance that at least they weren't thinking about hand-to-mouth contact more than they normally would be. What we told them was, we said that we are interested in studying their workplace exposures, and they knew that we were because we were taking these wipes as well. I mean, we were taking the mouth wipes, so maybe people caught on that way, but nobody really said anything about that. So I think that, they just think, well, it's some kind of mysterious study. I don't know what they're doing, but so it's not, there are limitations associated with this, but I think most people assumed that we were trying to look at what tasks they were doing. So people would often kind of try and narrate to us what we were doing, which we discouraged them from doing because we wanted them to be as normal as possible. Now there are other ways you can do this. What we would really like to do is we would like to get access to kind of CCTV footage from factories and then just look at those, but we weren't willing to find anybody who would give us access to that. So this was the next option. These are the results of the observational work. So I have here the frequency of contact per hour, the average, median, and the maximum. I mostly looked at the median because that seemed to be, just because that was the most statistically relevant in this case. So there are different types of contact. There's hand-to-oral contact, where somebody puts their hand directly in their mouth. Hand-to-perioral contact, where somebody puts their hand on their perioral area. And then there's object-oral, etc., arm-to-oral, and so on. And then we added them all up and had total contacts with either the mouth or the perioral area. So there were a median of 6 contacts per hour among this group of people. And most of those contacts were when somebody touched the area around the mouth with their hand. So of this 6 here, 4 of them were hand to perioral, or on the average, 7.9, 5.9 were hand to perioral. The next most common was object to perioral, where somebody touches an object to their perioral area. It was less common for people to actually put things in their mouth, but people were touching their face not quite a lot, but people were touching their face. Then we looked at some of the things that might have an effect on these contact rates. So we were interested in PPE, particularly gloves and respirators, and what kind of effect they had on contact. So up on the top bit here, there was no difference in the rate of contact, the number of contacts per hour between, this is actually total contact, any kind of contact at all. There was no difference between workers who did and did not wear gloves during the hour-long observation period. So the p-value is 0.764, and you can see there's no difference really here between people who did and didn't wear gloves. So then we kind of, we did actually record when people put gloves on and when they put them off. So we knew if someone was wearing a glove when they had a contact and when they weren't. So for every contact we recorded if they were wearing gloves or not. So we were able to kind of go a bit deeper and say, okay, among the workers who did wear gloves, did they contact their face more frequently while they were wearing gloves than while they were not wearing gloves, or the other way around? And we found that people were more likely to touch their hands during times when they were not wearing gloves than times when they were wearing gloves. So this is I kind of confused myself a lot with this, but the difference is here. So people who wore gloves at all were no different from people who didn't wear gloves at all. But among the people who did wear gloves, they did touch their face more often while they were not wearing the gloves. So, and we found the same thing for respirators. So we think that respirators and gloves do have an effect on contact. So people don't touch their face as much when they're wearing gloves or respirators. And the respirators, it makes sense because they are, you've got a respirator on, so you can't touch your face. But we did actually see people kind of resting their respirator on their chin or on their lip, and that counted as a contact. So another thing that we looked at was the effect of task on the frequency of contact. So we divided up all of the we categorized tasks into different types of tasks. So we had manual tasks where people are working with their hands, desk or paperwork where people are not really working with their hands, they're at a desk or maybe on the phone or something like that. Operating machinery, that's, people aren't directly doing a task with their hands, but they are operating some kind of machinery. Or between tasks, which is when people aren't really doing any task at all, they're maybe walking from one area of the factory to another, or they're kind of waiting for some kind of operation to finish. And this actually happens a lot, especially in the maybe I don't know. I don't know why, but this happens a lot. So there were a lot of people did spend a lot of time when they weren't really involved in any kind of task at all. And what we found was the rate of contact goes way up during these times. So this had by far the highest rate of contact was during this between task thing. So that's interesting because it shows that, because we did actually previously know that people don't really touch their face very much when they're busy working with their hands. But people who do work jobs where they're busy working with their hands, they have times in between these busy periods where they're not busy, and then they touch their face then. So that's so that was interesting for us. And then we divided people up to look at the percentage of the observation period that they spent kind of doing, between tasks where they were. So among people who spent 10% of the hour between tasks, or less than 10% of the hour between tasks, they had significantly less, a significantly smaller rate of contact than people who spent 30%, greater than 30% of the task. So you can see with the percentage of time spent between tasks, the average rate of contact and median rate of contact goes up. Another thing that we found was significantly related to contact was smoking and nail biting status. So we asked people, do you smoke and do you bite your nails? And people said yes or no, and we believed them, because we didn't have any other way of finding this out. So we've found that people who told us that they bite their nails had a higher average rate of contact and than people who told us that they didn't bite their nails. And I should note that we didn't notice anybody biting their nails while we were doing our observations. We didn't see anybody biting their nails, but people who said they bite their nails did touch their face more frequently than the people who said they didn't. And the same with smoking. Very few we did see some people smoking. Actually, we did see some people like sneakily smoking when they weren't supposed to be outside. But that didn't happen that much. There were maybe, out of all the observations that we saw, we maybe, I don't know, maybe 5 of the contacts that we observed were related to smoking. But again, people who told us that they smoked had a higher rate of contact than people who told us that they didn't smoke. So it seems that some people are kind of more likely to touch their face than others. And maybe you can predict this by knowing if they bite their nails or smoke. Oh yeah, and there also, we did look at we looked to see if there was any relationship between nail biting and smoking, and there wasn't. So these are not the same people necessarily. Okay, so that concludes the points I want to make about the rate of contact. So actually, I should say one other thing. So another thing that I took away from these observations is that this does actually happen. People do actually touch their face, because we weren't sure, because I think a lot of people sort of assume that it's only children who do this kind of behavior, but adults do it, and they do it in the workplace. So so that kind of says to us that maybe this route of exposure is real. So Then this is just kind of an overview of the measurements that we did, the hand and perioral wipes that I talked about earlier. So this is we kind of put all the measurements together, and we found that there was a correlation between exposure on the right hand and exposure on the perioral area. So that, and which is what we expected to find, and it is what you would expect to find if people are touching their face and there's transfer happening there. So we did multiple linear regression where we put a few different things in a model together to see if they affected the amount on the perioral area. So we used the amount that we measured on the perioral area as the outcome variable, and we found that for these four metals, the amount of metal that we measured on the right hand was significantly and positively related to the amount that we found on the perioral area for three of these metals, and for this one it's nearly significant. So there just seemed to be, so we have quite a lot of evidence that there is a relationship between the amount on the hand and the amount on the face. There was actually no relationship in our regression between the rate of contact between the hands and objects in the mouth and the amount on the amount on the perioral area. So that says that either the rate of contact isn't important, or maybe the amount on the hand, or maybe this exposure on the perioral area isn't actually coming from the hand. And the use of respirators, that was related to exposure as well for two of the metals, and we're not really sure why that is. I mean, one possible reason is that people who use respirators, they are using respirators because they're in sort of high exposure areas. So maybe that's why they have higher just exposures in general. But we're not really sure why we found this. We wanted to also look at gloves and what relationship that glove use had on the amount on the perioral area. But in this asterisk down here, you see 93% of the workers used gloves. So we didn't have a big enough kind of group of workers who didn't use gloves in order to actually look at that. But we were able to look at respirators because they were about half and half. Okay, so our main kind of conclusions that we took from the fieldwork is, one, contact with the perioral area is more common than contact with the oral area. So people touch their perioral area, the area around their mouth, but they aren't so likely to actually put things in their mouth. Time between tasks, PPE use, and smoking or nail biting status are determinants of the contact frequency. Monitoring of exposure on the perioral area may be a suitable surrogate for measuring inadvertent ingestion exposure, because there does seem to be some relationship between the hand and the perioral area. The amount of exposure on the hands is a stronger predictor of perioral exposure than the frequency of contact. So those are the main things that we took away from the fieldwork. So the next phase, the last phase, we took all the information that we had and we used it to develop a model. And I don't want to really get go into too much detail about how we developed the model, because what I want to get across is because this is kind of an introduction, I guess, to inadvertent ingestion exposure, how it happens, what some of the determinants are. So I don't want to get into a lot of modeling details here. So I'll just briefly summarize the model and how it works. It's called the Ingestion Exposure Assessment Tool, or IEAT. It's freely available, like the database that I mentioned earlier. It's on, both of those are available on the IOM website. So anybody can download it and use it. We developed it in MATLAB, which is a mathematical computing program, but you don't need to have MATLAB in order to use the tool. It's a it's just an executable file, so it's a like a computer program. You can download it on your computer and just use it. And it estimates exposure on the hands and exposure on the perioral area. And the way it works, basically, it estimates exposure based on a series of transfers between surface, hands, gloves, and the perioral area using the following equation. So E is exposure in micrograms per square centimeter. And that we find that in the model by multiplying the estimated loading on the surface or the hands by the surface area that is coming into contact with the hands or the perioral area. And we multiply that by the transfer efficiency, and then multiply that by the number of contacts. So we use this general equation, and we use all the data that we collected in the field work and the lab work and the literature review to kind of to figure out what these the values for all these variables in a number of different scenarios. And so this is the tool. This is what it looks like. So you have this start page. Click start, and then it guides you through a series of questions about things that about the exposure scenario that you're interested in. And so you enter the general properties of the substance that you're interested in assessing exposure to. Some questions about the job profile, so the kind, the task that you're interested in and the workers that you're interested in. It asks you some questions about them. And then there's some questions on immersion, spills, and splashes, and that is something that I didn't actually talk about earlier. It's basically what we found from the literature review is that people who immerse their hands into some kind of substance or get spills and splashes, they're going to have much higher amount of material on their hands than people who don't have this. So that it asks some specific questions about that, and then it asks some questions about PPE. So the user answers all these questions on kind of screens like this, where it's like, what is the physical? I don't know what that says behind there. Actually, I've forgotten. But it asks like, what is the percentage of the material in the formulation? So ask all these questions in drop-down menus. There are these question marks where it kind of gives some guidance on how to answer the questions. And then at the end, it gives a little summary of all the things that the user has entered. And then you can run the model. And then this is a mock page, but what it would have here is have some kind of number. So it has exposure estimates. So this is the potential inadvertent ingestion exposure in micrograms. So that's the estimated amount of the substance that you would expect to find on the perioral area, and the micrograms per square centimeter that you would expect to be on the hand. And then it has kind of an upper estimate, which is a very conservative estimate. And then there's also some guidance here. Sorry, how do I interpret these results? It gives people some guidance on how to interpret these results. So it is like dermal exposure. There are obviously no exposure limits, so it is kind of hard to once you have these results, how are you actually going to interpret it? You can use toxicological data, which is the same thing people do in dermal exposure usually. So we do recommend that this tool, this tool is not for, it's only really for people trained in occupational hygiene, and we actually do recommend that people have some kind of background in dermal exposure. So it is for expert assessors. And we do in the tool, we provide some examples of some kinds of ranges of perioral exposures that have been reported in our study and in the literature. So this is the problem that you get this kind of estimate and you don't know what to do with it. However, we do think that what it could be useful for is for people to sort of rank different jobs and see which ones might be the most might have the most exposure by inadvertent ingestion. So it's kind of a risk assessment tool. we validated the model that we made against some hand and perioral wipe measurements from some work that we did and from some previous work. So we have data on metals, pesticides, and cytotoxic drugs. We had 3 exposure assessors. They looked at descriptive information about all the different tasks, and they filled in model. They went through the model and found and created a model estimate of the exposure, and they were blinded to the measurement data. And then we compared the model estimate from these exposure assessors to the actual measurement from our exposure scenarios. And we found that there's a good correlation between the modeled perioral exposure from the IEAT model and the measured perioral exposure. So the lowest ones are down here. These are the cytotoxic drug measurements. They have quite low exposure. Pesticides, agriculture, they're kind of in the middle, and then the metals are up here. And you can kind of see it did actually work best for metals. And it didn't work so well for pesticides, but at least it kind of ranked them in the right sort of range. And it didn't work so well for the cytotoxic drugs either. So it's not, yeah, it is a very, very preliminary model, but I think it does sort of show that some of these things these concepts that we're looking at, we're kind of on the right track with some of them. There was good correlation. This is the range of correlation for the hands. So this is the model estimate of hand exposure and the actual measurement of hand exposure. This is the range of correlation for the perioral. It works better for perioral than hands. And then we had good agreement between the assessors as well. Another thing is that in this model, it generally overestimates exposure by quite a lot. So it overestimates perioral geometric mean exposure by a factor of 7.4, and it overestimates hand exposure by a factor of 1.4. So it is overestimate, but that for a kind of preliminary model, that is actually kind of seen as a good thing because you would rather overestimate exposure than underestimate exposure. So it would be better to get something that is kind of more in the right range, but we're in the kind of typical range for this kind of screening model. So that's encouraging as well. So this is some things that we think this model might be useful for. As I said before, it's freely available on the IOM website, and it's designed to be used at a job group level. So we don't really recommend that people use it to differentiate between individual workers. We think it works better if you group people into kind of similar exposure groups and use it on that level. Its primary application is for risk assessment and screening, so to screen scenarios that you want to investigate further. It could have some applications for epidemiology, maybe. It could help with relative ranking of exposure groups, job exposure matrices, and possibly retrospective assessments, although that might need some further validation with kind of older data. And also, if anyone is going to use this, or if anyone was to use this for, especially in epidemiology, you would need to bear in mind that it is a conservative model. So conclusions of the overall work is that inadvertent ingestion exposure should be considered when assessing exposures to substances that are absorbed gastrointestinally. Obviously, not all substances are toxic when ingested, but if they are, then you should think about inadvertent ingestion. And exposure, we don't really have, we thought a lot about dermal exposure because there are a lot of parallels. Dermal exposure is not as well developed as inhalation exposure, and ingestion exposure is way worse. So it's in its infancy, but some tools are available. So I mean, there are ways you can study it if you need to. Hand wipe or rinse, perioral wipe, or this model that we have. And actually, another thing that I should say is we did find that that hand wipe, as I said before, the amount on the hand is related to the amount on the perioral area. So even if you only have some kind of hand measurement, you can make some kind of inferences about perioral exposures. So even that would be useful. And I also want to acknowledge all the people who helped me with this work. So there were a lot of people at the IOM in Edinburgh who were involved and who helped with field work, with doing the assessments for the models, and etc. And then the University of Aberdeen, that was my PhD supervisor was Sean Semple at the University of Aberdeen, and he provided a lot of help. The health and safety executive, Christine Northridge, was our contact there, and she helped with because they're actually the reason why they funded this study is because they are interested in exploring different routes of exposure. So that was helpful. And then we also had an advisory council that we met at least every 6 months to they gave me advice as I was going along. We had this is Yvette Christopher. She actually also did her PhD on ingestion exposure, so that was useful to have her involved. Eric Hillmans, he's done a lot of exposure modeling, and Violen, I can't pronounce her last name. She was a kind of industry representative that we had. So there were a lot of people who helped, and so I hope it was. I think it's a kind of a new topic that most people don't really know very much about. So I hope it was useful to get a little bit of an overview on it, and I would welcome any questions.
Thanks, Melanie. We're probably only have time for 1 or 2 questions, and I see one across the room and then one back here.
Delightful presentation, Melanie.
Oh,
Fabulous. So my question is, and this it's a parallel between the world of industry and wearing heavy gloves and things like that, and the world of healthcare work that wear very thin latex or non-latex gloves and things like that. That we know from experience that when you can't feel that you've got substance on your hands because you're wearing gloves, then you go around and you liberally put them everywhere, right?
Yeah.
Put the substance everywhere. And so I'm wondering, did you do any wipes of the respirators? Because it seems to me that the respirators would be heavily contaminated.
Yeah, no, we didn't do that. But the reason why we didn't is because there were all kinds of different respirators that people were doing, and we were kind of limited in our scope and budget. So we weren't really able to accommodate, validation of methods for doing all different types of respirators. But that's definitely something that we would like to do. I think that a lot of people have brought that up. And that is important because, as I said, we did see people sort of resting their respirator on their face quite a lot, and we don't know what's on the respirator, and there probably is stuff especially on the outside of the respirator. So that would be, I think, what we maybe could have done, which we didn't do, is just maybe even the inside surface of the respirator, the kind of rubber bit that goes around the face. We could have that would have been interesting. But then again, a lot of people use disposable respirators, and so that was a challenge. But yeah, that's definitely important.
Mm-hmm. Hi, thank you. So you look at the effect of the number of contacts on the injection exposure, but I'm wondering, what about the duration of the contact? Because this contact is different from this contact.
Yes.
So
yes, yeah. That I didn't mention this in the presentation, but people have looked at that in lab settings. It was one of the things that we looked at in when we collected this database of transfer efficiencies, and a lot of people have looked at that, and most people have found that there's no relationship between duration of contact and the amount transferred. So we didn't include that.
Hi, Mel. So since I'm not going to see you later, I'm going to put a quick question.
Okay.
So super interesting, the whole thing about the personal characteristics. I did wonder, did you see a gender effect?
No, because almost everyone was male. So yeah, but we yeah, that I wanted to study that, but it just turned out that there was one work site that we went to that had some women, and we did study them, but there weren't enough. So yeah, that would be interesting, definitely.
Okay. I'm sure Melanie's willing to take more questions after we wrap up here. And thank you very much, everybody, and thank you, Melanie.
Thank you.